I'm Neerumalla. I work as a security software engineer at Microsoft. I worked on SQL Server for 4 years. I was part of the SQL pen test team when we shipped SQL Server 2005. When I was working on SQL Server 2005, one of the tasks that I worked on was finding SQL injection issues inside SQL Server. So when I was working on that, I came across some code patterns where the code looked safe for SQL injections, but in some conditions, I could still either modify the developer intended SQL statement, or I could inject additional SQL statements. So I'm going to discuss about these new vulnerability issues, and then I'm going to provide some mitigations for that. I'll be using T-SQL code for most of my examples here. So I'll start up discussing some of the best practices that you need to use to prepare dynamic SQL statements for SQL Server. And then I'll take an example which is vulnerable to SQL injection issues. We'll fix it with those concepts. And in the second part, I'll show you some of the variants of the same code which is vulnerable to these new issues. Okay, go. Best practices for constructing dynamic SQL. In SQL Server, the way you delimit SQL object names or SQL identifiers, when I say SQL identifiers, I'm referring to SQL object names like table names, column names, and login names and others. The way you delimit them is different from the way you delimit string data. You don't need to worry about delimiting SQL object names unless you're using keywords for the object names, or if you have any special characters in the object names. In SQL Server, you can either use double quotes or you can use square brackets to delimit these. But the problem with double quotes is it's dependent on connection-based setting called quote identifier. If this setting is on, then you can use double quotes. But if the setting is off, then you cannot use it. That's why you can't rely on this in all the cases. And never use single quotes to delimit SQL object names. Always use square brackets. If you are using square brackets as the delimiters, then you need to be careful about how you escape these delimiters. In SQL Server, it's pretty simple. If you're using any delimiter character, you just need to double that up. So if you're using square brackets, you just need to double up right square brackets, not left one, but always double up right square bracket. Okay, here's the examples. If you look here, I'm trying to create a table with name employee with some special characters. You see here I have double quotes, left square bracket, right square bracket, single quote, and exclamation mark. But here in this statement, I'm using square brackets as the delimiters. When I'm using square brackets as the delimiters, I'm only doubling up right square bracket. I'm not touching anything with the other ones. So when SQL Server looks at this statement, it knows that this is the beginning of SQL object name and this is the end. Whenever it sees two consecutive right square brackets, it treats it as part of the SQL object name. So when the identifier is off, this statement is going to work. But if you try to use double quotes as the delimiters, then it's going to fail, mainly because this setting is off. When you turn on the setting, both the delimiters, you can use both of them. So again, you need to worry about delimiters only when you have special characters or when you're using keywords as your object name. Delimiting string data. These are like constant strings. Again, even here, you can either use double quotes or you can use single quotes. Just like before, double quotes is based on this connection-based setting. So if the setting is off, then you cannot, in this case, actually, you can use them as the delimiters. If it is on, then you cannot use it. But you can always use single quotes as the delimiters for string data. And any occurrences of single quotes within the string data, you just need to double them up. Again, here's the example. I have the setting on here. When I have the setting here, I'm trying to insert this mystery man with some characters. When I use double quotes, I'm only doubling up these double quotes. And because this setting is on, this is going to fail. You can see here. But if you use single quotes, in both the scenario where this setting is on or off, it's going to work. So if you know the object names or if you know the strings beforehand, then you know what to do. You know what delimiters you need to use, and you know what characters you need to escape. But if you're constructing dynamic SQL statements where you're accepting the data from the end user, then you need some automatic ways to do this. In T-SQL, SQL Server provides two functions which will be of use to us. The first one is quote name function. Quote name function is mainly designed for preparing delimited identifiers. It's pretty simple. It adds the beginning delimiter and it also adds the ending delimiter. And any occurrences of the delimiting character, it doubles them up. So if you look at the body of this sp_drop login store proc, you will see the way the dynamic SQL statement is being formed here. Drop login plus quote name login name. Because it's mainly designed for SQL object names, the default character to quote name is square brackets. So this is what, if you pass dbreader, this is the statement that gets formed. Drop login, left square bracket, dbreader, right square bracket. If you pass any square brackets inside it, quote name is going to double the occurrences of right square brackets, but it doesn't do anything with the left square bracket. So simple. You can also use quote name function to delimit string data. If you look at the body of this sp_password store proc, you will see the SQL statements that are being formed here. Alter login plus quote name, because login name is a SQL identifier. The default, we are using square brackets there. With password, because password is a string data, we are using quote name function with single quote character. See here, this one, those are the delimiters to represent string data. And because we have two single quotes here, basically it's a single quote character. So if you pass password as the password for this, the statement that gets formed is alter login, dbreader, look at the delimiters with password equals to single quote, that's the beginning delimiter, and this is the ending delimiter, and that's the password. But if you have any single quotes within the password, the quote name is going to double them up. So you can use quote name function to delimit SQL identifiers, or you can also use it on string data. But because quote name function is mainly designed for SQL identifiers, it has a restriction of sysname, which is nvarchar 128 characters in SQL Server. So if you pass anything greater than 128 characters to this function, it's going to return null. That's when you need to use replace function. Replace function, as it states, it's very simple. It takes 3 arguments, the character string. The second one is the find string. And the third one is what you want to replace with. So it finds all the occurrences of the find string and replaces them with the third argument. And there is no limitation on the strings. Again, escaping single quotes with replace. If you look at the SQL statement that's being formed here, create database, quote name, DB name, because DB name is a SQL identifier. On file name, replace function doesn't add the beginning and ending delimiters. It only replaces the occurrences of any characters. So in this case, you need to manually add the delimiters, beginning delimiter and ending delimiter, and see here, replace single quotes with 2 single quotes. These are the delimiters for string data. And when you have 2 single quotes within the delimiters, actually you're referring to 1 single quote. So if you pass C:\vac db single quote file, then this is the statement that gets formed here. See the way. Quote name versus replace. Quote name works for, just to highlight the points, quote name works only for character strings of length 128 characters. And replace function doesn't have any limitations. So always use quote name function to prepare delimited identifiers. Quote name is nothing but beginning delimiter, replace function with the ending delimiter. That's all. That's the difference between these 2 functions. Now that we know how to form a good SQL statements, Let's look at this example. I have the stored proc sp underscore set password, which takes 3 arguments: username, old password, new password, and I have a local variable add command, and then I'm constructing the dynamic SQL statement here. Update users, set password equals to single quote, here's the new password, where username equals to, again, username and password equals to the old password. What's the problem with this one? None of the variables are validated for data. So if it's a first order SQL injection issue. So if I pass something like single quote, semicolon, I can inject any SQL code here. Everybody knows this problem, right? Let's fix it using code name function. Update users, set password equals to, because code name is going to add the beginning and ending delimiters, and you're going to replace all the occurrences of single quotes with 2 single quotes, where username equals to code name, again username, and password equals to code name. So now we mitigated first order SQL injection issues in this code. We can also use replace function to do the same thing, to achieve the same thing. Update users, set password equals to single quote, replace all the occurrences of single quotes with 2 single quotes, followed by ending delimiter, where username, same thing here for all the variables. So just to highlight the key points till now, if you're preparing a delimiter infer, develop all the occurrences of right square brackets and add the beginning left square bracket and ending right square bracket as the delimiters. For string data, always develop the occurrences of single quotes within the string data and use the single quotes as the delimiters. We can use quote name or replace function, and the only difference between these 2 functions is quote name adds the delimiters and replace function doesn't. So, any questions so far? Is there any other problem with this code? The one that we just fixed? What about the original code? Can you all look at the code? Is there any problem with this one? So I have sp underscore set password, which takes 3 arguments: username, old, new password. And we know that there exists first order SQL injection issue here, right? None of the data variables are validated. So, but there is one more problem in this code. If you observe carefully, if you look carefully, all the arguments are of length 25 characters, but your command variable is declared as varchar 100 characters. If somebody passes all 25 characters for all the variables, then the SQL statement gets truncated. Some database products generate error, and some database products do not generate error. SQL Server, as of today, does not generate any errors on this one. It silently truncates the data. So what happens in this particular example? So in this particular example, if you pass 25 characters for all the variables, the command is going to get truncated right after AND operator. If you see here, I passed 25 characters as the new password, 25 characters for the username, and after the AND, because it can only hold 100 characters, the command gets truncated. In this particular example, it's not a valid SQL statement because it's not complete. So SQL, when this statement gets executed using exec statement, SQL generates an error. But because we added quote name function or replace function to mitigate first order SQL injection issues, what we basically did here is, earlier the command got truncated after AND operator. Even if I wanted to truncate it before, I didn't have the ability. But now, because we added quote name function, there is something that we can do. If somebody passes single quotes, quote name is going to double them up, right? So because of that, now we have the ability to truncate the command not after AND operator. We have the ability to truncate the command even before. In this example, if I want to truncate the command somewhere, I would truncate right after where username equals to username, some username. That way, I can set the password of any user without knowing its current password, without knowing his password. So in this particular example, if I really want to do that, if you count the number of characters that's consumed by update users set password equals to, that expression consumes 26 characters, and space where username equals to, it consumes 16 characters. Let's say we know the existence of any user account in the app. Let's say we know the existence of administrator account in the app. Because code name is going to add the delimiters in the beginning and in the end, so single quote, administrator, single quote, it consumes 15 characters. Now we need 100 minus 26 minus 16 minus 15, 43 characters, so that we could truncate the command right after where username equals to class. So, but you can only pass 25 characters as the new password. How do you get around? I mean, but you need 43 characters to truncate the command. How do you get around that? By using single quotes. Because if I pass single quotes, code name is going to double them up for me. So pass some single quotes so that code name returns more characters than 25 characters. So in this particular example, because it's a password, people might be checking for password complexity rules. Just pass like 18 single quotes and a bunch of other characters so that you will get past those rules. So here, if I pass like 18 single quotes and 5 other characters, code name is going to add the beginning delimiter and ending delimiter. That way I can truncate the command right after where username equals to administrator. So, any questions on this issue? What happens if somebody uses replace function instead of codename function? Can we exploit it now? The only difference between the previous code and this code is, in this code, developer has explicitly added the delimiters. In the previous code, codename adds the delimiters. So there's no difference between the previous code and this code. So I can pass the same data as I passed before and truncate the command. So that's the first issue. Like, you can modify the developer intended SQL statement by truncating the command. How do you mitigate them? Calculate the buffer length properly. So in this case, because new variable is declared as 25 characters, codename is going to return 52 characters when all the characters in the variable are in the parameter are single quotes. So you need 26 for update users class expression, 52 here, 16 here, 52 here, 16 more here, and 52 more here. So you need at least 214. Because it's a varchar, you don't have any problem in declaring more than that. So avoid buffers if possible. Again, you don't need to have a separate variable for storing the command. You can directly execute within exec statement. Sorry. Or use parameterized SQL statement. You can use sp underscore execute SQL in Microsoft SQL Server to use parameterized queries. Or you don't need to construct dynamic SQL for DML statements. That's why, like, for most of the applications code that you write, you don't write dynamic SQL. I'm just using T-SQL code here so that just for demonstration purpose. Let's take a look at one more variant of the same problem. I have the same code, just like before. I have sp underscore set password, which takes 3 arguments. But here, the only difference is I have 3 more local variables, which are quoted underscore username, varchar 25, quoted underscore old password, varchar 25, quoted underscore new password. But here, I have enough buffer in my command variable. And what I'm doing here is I'm storing the code name, the written value from code name in these new variables. This is one more variant of the same problem that I've seen. So, but you have enough buffer here in command variable. Can you exploit this one? What's the problem with this code? The truncation doesn't happen here, but the truncation happens here. So what happens if you pass 25 characters? quote name is going to add a beginning delimiter, and then there will be 24 more characters followed by a single quote. But because this variable can only hold 25 characters, the last 2 characters will be truncated. So what you will end up having is single quote followed by 24 characters, because the last 2 characters will be truncated. So what happens in that scenario? Your statement becomes update space users set password equals to, this will have a beginning delimiter, beginning single quote followed by 24 characters. Because we don't have a ending delimiter, we'll have space where username equals to, and this quoted username will have the delimiter. So the entire stuff becomes the new password. So the statement becomes update users set password equals to single quote 24 characters space where space username equals to followed by single quote. That becomes the password, and then you have the ability to inject SQL code using the username. That's exactly what I explained here. So if you look at the command, update users set password equals to 123n space where space username equals to, this quoted username will have a beginning delimiter, so this entire stuff becomes the new password, and you have the ability to inject SQL code using username. You can calculate the buffers and mitigate it. Okay, what happens if I use quote name instead of, what happens if I use replace instead of quote name? Here the developer is actually, he is explicitly adding the delimiters. What's the problem? We have the same problem just like before. We have these variables declared as BlackHat 25s, and we are storing the return values from the replace function here. So can we exploit this one? The only difference between the previous one and this one is here there are hard-coded delimiters, single quotes in the beginning and in the end. Just like before, if you pass like 25 characters, replace function is not going to change anything. So the trick here is to make sure that the ending delimiter becomes part of your new password. How do you make that happen? If you pass single quote as the 25th character, replace function is going to double them up. So your 26th character also becomes single quote. But because this variable can only hold 25 characters, the 26th character gets truncated. So whatever you pass, it comes across as the same thing. So you'll have 24 valid characters followed by a single quote. So that way, your statement will become update users set password equals to single quote, 24 characters, single quote, there'll be this single quote. So then it becomes as part of this new password. So that's exactly update users set password equals to single quote. This is the data that we passed, and the second single quote is the one that's hard-coded by the developer. Space where space username equals to. This entire stuff becomes your new password, and just like before, you have the ability to inject SQL code using the username field. So in this case, basically you have the ability to inject SQL code by truncating the command, by truncating the variables. How do you mitigate it? Calculate the buffers probably just like before. If you look at the nature of these problems are not specific to T-SQL code. In fact, in MS SQL Server, these problems are not actually serious in T-SQL code, but if you have any applications written in C and C++ code, that's where the real threat will be. So I have the same code, but in C here. So dword, change pass, I have the same functionality here, change password, which takes 3 arguments, username, old password, new password. And I have 3 cat star pointers here. Let's say I'm calculating the buffer length properly. So if the length of the passed in parameters is n, let's say I'm allocating 2n plus 1. I have a string cch printf, which is equivalent, which is the safe version of s printf. This guarantees that you don't have any buffer overruns, and so. But if you see here, SQL command can only hold 100 characters, just like our T-SQL code example. So just like before, the truncation is going to happen in this SQL statement. How do you mitigate it? By checking the written values in this particular example. You can still, You can fix it by calculating the buffers. At least if you had checked for the written values, you can catch them. This is the C equivalent of the SQL injections by truncation example that we have seen before. I have 3 local variables which do not have enough buffer. If you see here 26, 26, which are hard-coded. And then this code is not checking for the written values from the replace function, and it's also not checking the written value from the strings this is printf. How do you mitigate it? Just check the written values. So there are 2 issues that we discussed: SQL modification by truncation and SQL injection by truncation. SQL modification by truncation happens by truncating the SQL command buffer, and SQL injection by truncation happens by truncating the variables. And truncation issues are not specific to T-SQL. You can find them even in the apps written in C and C++. When we first identified this problem in T-SQL, we actually wanted to generate the error. But there were some reasons why we couldn't fix it. For most of the apps that need to use DML statements, you don't need to construct dynamic SQL. And in SQL Server, by default, when you execute a stored proc, it gets executed under your context, by the caller context. So even if a stored proc has a SQL injection issue, if you try to exploit it, you only get to execute the code under your context. Because there is no context switch, there's no, those are definitely bugs, but they won't result in security issues. The third one is this behavior has been like this since the beginning. So we were worried about backward compatibility. For example, there are some more scenarios where, let's say you escape the variables in one store proc, but you pass that to a different store proc, which, for example, let's say you have 100 characters here, but the other store proc only accepts 25 characters. The truncation can happen even in those scenarios. So, but we'll be fixing them mostly in the second one, in the next versions of SQL Server. As I said before, anywhere you write dynamic SQL code in T-SQL or C++ applications, you'll have these issues. You might have these issues. Finding SQL injection issues, I generally rely on code reviews. So I identify all the APIs that are used to execute dynamic SQL statements. I review the construction of dynamic SQL and review the buffers that are used in the dynamic SQL. How do you mitigate them? Call code name or replace function directly inside the command, or calculate the buffer length properly, and in C and C++, check the written values. We publish this information on MSDN article, so you can find some of the information there. So, any questions? Cool. Thank you.